Good morning, class. All right, I'm so sorry for being a little late today. There's just so much traffic. Let me go ahead and unpack my stuff here. How's everyone doing? Pretty good? All right, awesome. Well, I'm sure you had a little bit of traffic coming in. I know for sure I did. All right, so let's go ahead and open up all your workbooks for today. We do have a really quick session, so we'll go ahead and jump straight into it. All right, my name is Professor Miss Pearl. I'm sure you've seen me in our last lesson, but if you don't remember, I'll go ahead and put my name up here as well. I am going to be your substitute professor until your teacher comes back. Let me go ahead and put these away. The weather has been beautiful. Has everyone been able to go out? Yeah, that's wonderful. All right. Okay, I'll go ahead, and today's date is 2025. It's February 14th. Everyone knows what that is? Valentine's Day, right? Of course. Happy Valentine's Day to you all. We'll go ahead and get started. I'll go ahead and put my name right here. All right. So again, feel free to take some of the seats up here if you don't have any space. I'm not gonna bite, promise. All right, so let's go ahead and get started. So from our last lesson, we have learned a little bit about area and perimeter, right? Yeah, that thing with the shapes. So can anybody tell me what's the difference of an area and a perimeter? Okay, so area, you don't have to give me the exact definition. You can give me a little bit of a similar definition or describe it how you would like. I think this isn't working so well, so let me try a different pen right here. This is also not working well. It's always the problem with some of these. Let me just go ahead and try erase that. All right, great. Thank you so much for your description. So you said that the area is basically getting everything that is inside the shape, right? We're exactly measuring out the inside. So area is kind of like whenever we say area, I always make sure, kind of think of it as an area model too, right? I'm sure you learned in multiplication about what the area model looks like. Very similar to that, area also is applicable to when we are finding area and perimeter. Perimeter. Who can describe what a perimeter is? Yes, over there. In the blue shirt, yes. Perimeter is essentially the length of the outside of the shape. So we'll just go ahead and put it's the inside and the outside. I want to keep things simple. So what I'm going to do is I'm going to split the board in half, and we're going to start with a sample problem. So everyone should be on page 3, right? On A, there should be a problem with a square. You're going to see a square with, now let me try to find a marker that even works, because none of these are working. It's always like that, isn't it? All right, so we have a square. It's just a regular square, right? What's the characteristics of a square? Right, a characteristic of a square is essentially, right, it has all the same sides. So the top, the left, the right, and the middle should have the same sides. Now, what kind of unit do you see? What is it measuring by? It's measuring by 3 inches. All right, so if that indicates, how do we know about these other ones? Yes, you in the green shirt. Yes, we know that these are also 3 inches. Exactly. So since these are 3 inches, we have 3, 3, 3, 3. Right, we are able to find the area. Do we need to know all the sides to find the area? Usually the most important thing is length times width. Exactly. So I'm going to go ahead and put that in a different color. So length times width is the formula for an area. So essentially, we'll label this as length, and this will be our width. Width for W. Right, so since we have 3 and 3, we're going to put that in an equation. Can anyone tell me what 3 times 3 is? Right, 9. And what are we measuring in? Do we know? Is it feet, liters, inches, right? I know it's a little faint. Again, if you're not able to see my board, you can go ahead and come up a little closer. So we have 9 inches. That's how we found the area. Now, let's try the same problem for the perimeter. Now, before we actually start, do you think, and I want to get a raise of hands, do you think that the area in the perimeter will equal the same? Raise your hand if you think the perimeter and the area will be same. Okay, we got a couple hands here. All right, go ahead and put your hands down. Raise your hand if you feel like the area and the perimeter will be different. You think a perimeter will be a different number than what we got here. See a couple hands here as well, okay? All right, let's go ahead and draw our perimeter. I'm gonna draw the same shape. Try my best with my drawing skills. And we already know that we have 3 inches in all the sides, right? Exactly, since we have 3 inches in all the sides, what is the formula for a perimeter? Does anybody know? Especially for a square or rectangle, there is a specific formula that you can use to make it a little bit easier. There's 2 ways to kind of do it. Is everyone being a little shy? It's okay. Okay, so I don't want to call on anybody, but is there anybody else who wants to volunteer? Yes. Yes, you're right there. Okay. And also, please go ahead and put your name tags up front because I don't know your names yet. So please do so. That way I can actually get to learn your names. All right. So yes, we do have a formula for the perimeter. And what is that? It's 2 length plus 2 times width, right? 2 times length times 2 times width. Why do you think the 2 is there? Because we have 2 sides, right? And we know, especially for a square, right? And a rectangle as well, right? Works for those. They are going to be identical on opposite sides, right? So even if this is a rectangle, we know that the width won't change and the length won't change either. Right, so we're gonna go ahead and pop this in a formula. That's what I like to do, love my formulas. So let's go ahead and start figuring out what 2 times 1 of the length is. So we know the length is the one that goes horizontal, right? So the length is 3, so just gonna have one number, plus, I'm gonna move these over here, 2 times width. And what's the width again? 3, yes, exactly. Okay, so let's take a look at that. So 2 times 3. Can anybody tell me what 2 times 3 is? 6, right? What is 2 times 3 as well? Letter 6. We're going to go ahead and add those up together. 6 plus 6 is 12. 12, don't forget, inches. Right, so since we have 12 inches, what do you notice about the area versus the perimeter? There are different answers, right? So anybody who has raised their hands and thought that the area and perimeter will be different, you are correct. If you haven't, that's perfectly fine. I know this is our first lesson, but again, just wanted to show you a different image of what that looks like. So again, this is one of the most basic shapes that we can do for area and perimeter. It's very easy to get confused, but you have to make sure you know what's the difference of an area and a perimeter. Another thing you can also do, if I didn't want to use multiplication or this formula for a perimeter, what can I do as well? You can basically add every single point all around, right? Because let's just say is, for example, we somehow have a different shape. Again, just imagine it's a different shape, but we have 3 inches here, we have 2 inches here. Let's just say we have 1 inch here, and then we have 4 inches here, right? Can you use this formula for something that has different inches everywhere around? Probably not, right? And let me get a little closer so you can actually see. I know it's a little bit hard to find and see. Maybe that's a little bit better. Okay, cool. So here you can see that they have different inches, right? Different lengths. So here, what I like to think of it as this. I always think of perimeter as Peter. Peter is running around the block to hit all the different grocery stores and making his way back. He's not going to go from grocery store and come back. He's going to go all around the block to make sure that he hits every single grocery store so he can make his mom happy. Right, so this is one analogy that I've learned. Peter, right, with the P, reminds me of perimeter. So let me go ahead and draw that. Let's say Peter's house is right here in this dot. I'm just going to write Peter right here. That's Peter's house, okay? And Peter wants to make it all the way to the block and make it back without turning, just making it all the way throughout the shape. So for him to do that, what do we need to do? What kind of operation? Is it division, multiplication, addition, or subtraction? Addition. Addition, right? Because since they are all different values, we need to add 3 plus 2 plus 1 plus 4. Let's go ahead and add that all together. What's 3 plus 2? That's 5, okay? And what's 1 plus 4? That's another 5. All right, so what is 5 plus 5? Everyone should know this. 10 in inches, right? Because we have not changed the units. I know it's a little hard to see the answer. I'll make it a little, okay, 10 inches. So that, again, is another method to get to our perimeter. So I hope that lesson helped. What I want you to do, we're going to focus on just the squares, right? I want you to get familiar with squares and rectangles. There in the page 3 that you're on right now, you should have 4 problems you can do on your own. I'm going to go ahead and walk around. If you need any help, just raise your hand. Otherwise, I'll swing by and I'll just check on your work. Sounds good? All right, any questions before we start independent work? All right, sounds good. Again, if you need anything, please let me know, and I'll see you in just a little bit.